So let's start with supervised learning. In supervised learning, a model is trained using a labeled dataset. So what exactly a labeled dataset? So for each input in labeled dataset, there is an associated output. Think of it like a dataset with answers already filled in. Let's look at an example email dataset. We have two columns, provider and label. Notice how the emails from ABC and XYZ are marked as spam, and the emails from 123 and 456 are marked as not spam. Now our model has an exact output knowing from which company the emails are spammed and which company the emails are not spammed. And this is a label dataset because in each input has an associated output already filled in. With supervised learning, the model learns the relationship between the features and labels, allowing it to make prediction on new data. So in this case, when we give a new email to the model, it predicts whether the email could be spam or not spam. So now let's look at another example, which is bank loan repayment dataset. So here we have few features such as age, sex, education level, income level, marital status, and then the output saying whether the previous loan has been paid or not. Now, for example, consider there is a new person who tries to apply for the loan. Now, our model will predict based on the given data. Consider the person is having a master's degree with good level of income and married. Now, our model has learned that people with similar profiles previously had paid the loan. So it says that yes, go ahead and approve the loan, the person can pay the loan. So if we see here, we have mentioned that the supervised learning understands the relation between a given set of features and a label. And these models are trying to foresee these relationships can then be applied to predict the value. And that's what's happening here. So the features here are the age, sex, education level, income level, and marital status. And the output is based on these features, whether a person is able to pay the loan or not. Now let's talk about two main categories of supervised learning, which is classification and then regression. So classification is nothing but predicting a discrete value, whereas regression is predicting a continuous value. So now let's see what these are. So classification is all about predicting a discrete value. It is used when we want to sort data into some categories. Do you remember our email example where we have categorized the output into spam and not spam? In this example, we have two categories. But classification is not limited to two categories. So we can have discrete number of categories. Another example would be like predicting a person's disease, whether a person is having a disease or not. So all these kind of examples will come under the classification where we can predict in between a discrete number of groups. And on the other hand, we have another type which is regression. So regression is nothing but predicting a continuous value. Let's take an example of house prediction model. So here we are not going to predict based on the categories. We are going to predict a continuous values based on some features. For example, a house with 2 bedrooms will have certain amount of price, and the house with 3 bedrooms in some location will have another price. So we cannot categorize these outputs. We need to go on a continuous values. And these are few examples of these algorithms. One is linear regression, logistic regression, support vector machine, random forest algorithm, and decision tree. These are few among many number of algorithms which comes under supervised learning. So how does building a supervised machine learning model works? Let's break it down step by step. So the first step is data collection. This could be a new data which we are going to collect or an existing data set. For example, in our previous example, we had a bank data set which was already collected. And once we are ready with the data, and the second step is feature extraction. So the feature extraction is nothing but we extract only the relevant features. In our previous example, we might have few more columns such as first name, last name, mobile number, email, etc. etc. But we have extracted only the relevant features like income level, marital status, what is the education level, etc. The ones which actually influence the model prediction. And the step 3 is model training. We train the model on a portion of the data. Typically, we split the data set. Let's say 80% for training data and 20% for test data. Considering we have 1000 rows in our entire data set, We use 800 rows for training and 200 rows for testing after the training. So if you see, that is what the next step is, model evaluation. So once we train the model with 800 rows, which we have given as a training data, then we can test the model with remaining 20% and check if the model's prediction aligns with the actual outcomes. If the model predicts correctly on the new data, then it's fine. Else we need to fine tune the model again. Alright, now let's move to unsupervised learning. Unsupervised learning doesn't have a label dataset, which means it has a dataset without any labels, just only features. The model finds hidden patterns among the dataset by itself without the predefined outputs provided. For example, imagine an image dataset. The data points might include various images without a predefined output. So now the model doesn't know what each image represents. So the model itself will categorize by what it has observed. So there are two main categories of supervised learning. One is clustering and another one is the dimensionality reduction. Clustering is where the model divides the entire dataset into the clusters or the groups. For instance, if we feed an image dataset to a clustering algorithm, it might group the images of cats, birds, dogs separately, even though we have not mentioned any labels. Even though we didn't tell the algorithm what these groups are, it finds similarities and forms the clusters on its own. And next comes the dimensionality reduction. While keeping the important information intact, dimensionality reduction algorithms will try to reduce the number of features in a dataset. So let's discuss what dimensionality reduction in our future videos, but for now, this is what a brief of. And then a few examples of unsupervised learning are k-means clustering, hierarchical clustering, principal component analysis, and etc. Now let's see the steps of building an unsupervised algorithm. The steps for building an unsupervised algorithm is as same as supervised algorithm, but here the focus is on finding patterns. We start with data collection, which means gathering our data, and then we go for data pre-processing, means cleaning our data and removing the unnecessary features. And then comes our model training. Since there are no labels given in the dataset, the model tries to find its own patterns. So once the model finds the patterns, it divides the data into clusters. Once the clusters are divided, then we can analyze the clusters. And then we utilize the insights which we have gained from our clusters. For instance, if we are analyzing the customer's data, clusters might reveal the group of customers who have the same purchasing pattern. So by analyzing these clusters, we can find those customers who buys only during the festive offers, and we can send them a bunch of cold emails regarding our festive bonus offers. I hope this video gave you a clear picture on the fundamental concepts of machine learning. If you are having any queries, please post them on the comment section. Thanks for watching. Let's meet in our next video. Until then, chill and code.